Hi guys, it's Miss Leslie and I'm coming to you with a video about dilations. This video in combination with the motion rules video that you guys have already saw should help us get through the next lesson, which is lesson 5. Okay, so guys, first thing I want to do is talk about what a dilation is. This is my interpretation of what a dilation is. A dilation is when a prime image, and guys, please remember that a prime image is your new image, has been enlarged or reduced based on the scale factor. Okay, so guys, what you're looking at is your pre-image, and your pre-image is going to be either bigger, which is called an enlargement, or smaller, which is called a reduction based on what the scale factor says. So guys, let's talk about the two types of scale factors you're going to come across. If your scale factor is greater than 1, your new image or your prime image is going to be an enlargement. So guys, I want you to think about all the kinds of numbers that are bigger than 1, 2, 10 fifths, 7, 9, all of those numbers. If your scale factor is greater than 1, your new image is going to be bigger than your pre-image. If your scale factor is less than 1, that's going to result in a reduction. So all of your fraction numbers, 1/2, 3/4, 0.73, if you're taking that scale factor and it's smaller than 1, your new image or your prime image is going to be a reduction. So guys, let's talk about how we're going to figure out, using the scale factor, what type of image we're going to have. What you're going to do is you're going to take your pre-image, you're going to multiply your pre-image by the scale factor, and that's going to give you your prime image. So you guys see you had your original image, a triangle ABC. I'm going to multiply the scale factor by ABC to get A prime, B prime, C prime. And see, you're either going to have a reduction or an enlargement based on the scale factor. Let me show you guys an example of having a reduction or an enlargement based on what the scale factor is. Okay? So guys, I've got my trusty coordinate plane here, and I've got my pre-image, which is line segment AB, graphed on the coordinate plane. You see that it lies in the 4th quadrant, and most of the time, it does not change its orientation. It's either just going to get bigger or it's going to get smaller. So guys, the only thing that you need to do is name the coordinates for vertex A and vertex B, and then apply the scale factor to find A prime, B prime. So the coordinates for A is 3, and then you have to go down on the y-axis, -3. That's for A. And B is 5 and -3. I'm going to take my scale factor of 2, and we already know 2 is bigger than 1, so it's going to be an enlargement. And I'm going to multiply my scale factor by A and B to get A prime, B prime. So let's multiply. 2 times 3 is 6. And 2 times -3 is -6. B prime, we'll take the same scale factor 2 and multiply it by 5 and 3. 2 times 5 is 10. And 2 times -3 is -6. So guys, what used to be A at 3, -3 is A prime, 6, -6. What used to be B, 5, -3 is now B prime at 10, -6. Let's graph these coordinates. Let's graph 6, -6. So I'm going to the origin. I go over 6 and then down -6. There's A prime. And B, which used to be 5, -3, is now 10, -6. So I'm going back to the origin, going over 10, and going down 6 to get B prime. Okay, so guys, when we compare AB to A prime, B prime, you can tell the A prime, B prime is a little bit larger than AB, and it should be because our scale factor was greater than 1. So this is an example of an enlargement. All right, let's look at an example, guys, of a reduction now. So, guys, I've got our next image, which is triangle JKL, and we're going to have a scale factor of 1/2. You know, guys, 1/2 is less than 1, so we already can tell that this is going to be a reduction. But what we need to do is name each coordinate and then multiply 1/2 by each coordinate to find our image J prime, K prime, L prime. Okay, so let's name coordinates for J. J is at 6, 7. K is at 4, 2. And where's L? At 8, 2. What I'm going to do, guys, is take the scale factor and apply it to each x and each y and then graph what J prime, K prime, L prime should look like. So let's multiply 1/2 times 6. 1/2 times 6, J prime is going to be 3. And 1/2 of 7 is 3.5. Let's do K. 1/2 of 4 is 2. And 1/2 of 2 is 1. Then L prime is going to be 1/2 times 8 is 4. And 1/2 times 2 is 1. So guys, what used to be 6, 7, 4, 2, and 8, 2 is now 3, 3.5, 2, 1, and 4, 1. Let's graph it and see if we really have a reduction. We'll graph 3, 3.5, so we'll go over 3 and up 3.5. So there's J prime. Let's graph 2, 1. We'll go over 2 and up 1. There's K prime. And then 4, 1, go over 4 and up 1. So there's L prime. So guys, there's your triangle. And look how much smaller it is. It's about half the size of your original triangle. So what used to be JKL is now J prime, K prime, L prime. And it is much smaller, or a reduction, based on the scale factor, because our scale factor was less than 1. So guys, I hope that that makes things a whole lot clearer for you about scale factors and about dilations. This, in combination with the motion rules video that's already been done, should help us get through lesson 5. So I'm going to go on and unlock that for you. But guys, you know, if you have any questions about anything, then you can text me or send me a message through Odyssey. All right, take care, guys.